Hi and welcome back to part 2 of the LaserShoe build. The next part we have to make is the fan unit. This is going to extract the fumes from the around where we're cutting and pump them outside basically, so we don't have to put up with them in our workshop. The whole unit will be based on one of these. This is a blower fan, typically from a computer. They're relatively inexpensive. I picked this one here up for $5 second hand. It's in good nick and will last me for years. They're designed to run continuously. They're very low wattage, but they do put out a lot of air and they can provide a lot of back pressure. You can't get that with a normal computer fan. If you get any pressure build up on it, most of the air just spills out the air, the side the air is actually being drawn in from. So these by far are the best to use. It's only a 12 volt fan. I'll be running mine off just a simple plug pack. Okay, so the first part is we'll be cutting out the MDF parts to build the fan unit, and they'll all be cut from 18mm MDF. Our parts are all cut out, and I've done a little bit of rounding over on the parts that need it, and a bit of fitting as well to make sure that my hose goes over the end of this, and the hose that comes from my LaserShoe actually fits in this piece nicely as well. So this is the fitting I'm going to put on my dust extractor hose that I'm going to use to take the dust outside. It's a what you might call a Fido fitting, I suppose. It's actually a tin of pet food, about 4 inches in diameter on the outside, and that goes nicely into a 4-inch hose. And I've just given it the sand of the outside of this, so it just fits very nicely on there like that. So I'm going to get a really nice fit. Though it doesn't need to be overly tight, it can be quite sloppy actually. There's no back pressure really created in the hose up to 6 meters long. So don't panic if it's a little bit on the sloppy side. Right, so the first part is the fan. This is the fan I'll be using to create the vacuum. And first thing we need to do is we need to mount it on the piece of MDF. And the first trick is actually figuring out which way round it goes. It will only go one way. So the way to do that is simply align the hole up with the inside of the fan and have a look at it on the outside, and that is wrong. So I'm just going to keep turning it around, position it, and that's wrong as well. So too is that. So this must be, there we go. That's the hole there. And this here goes like that. This piece will actually sit over the end of it there, so you can see there now where it should fit and the hole should line up. So we've got its orientation correct. What I'll do is I'll now just line the hole up here with the fan opening on the inside there. Turn it over. Make sure this edge here is parallel to there, and then I get some super screws, and I'm just going to screw it in place. The reason I'm finding this so easy is I actually did this previously. So now the holes are all aligned here, and this piece here will slide over like so, and it will sit on the front edge there like that. There. So it sits on the front edge here. So that's what you're aiming for. Once you've got that positioned right, everything will flow from that. Okay, the next piece to go on is this one here. It's around it's got a smaller hole. There's two of these large rounds, but one's got a larger hole than the other one. The smaller hole goes next, and it will align. These three holes will align, and there's a couple of extra holes in here. There's a couple of extra holes just in here as well, and they'll be to screw it into the side, so we've got plenty of holding there. A bit of glue on here. And I'm just going to put in some 25mm screws to start with. Right, that's the first piece glued here, and I'm just going to let this glue dry a bit before I move on to the front piece. So what I'll do next is I'll assemble this piece here. This is going to be the outlet port for the vacuum, or maybe it's the inlet port for the air from coming in. So this is going to have two pieces stacked on like this here. Again, I rounded the edges on this piece and on the outside of this one. Next I'm going to assemble the box, and again it's the same procedure. Okay, now we're at the point where we can assemble the output from the vacuum, and that's why we left this here to dry a little bit. It's because this bit here fits on here, just slides. It slides over the fan there and down here like so. Now if you find like here there's a gap, as I've got here, then with a file you can remove a little bit of the excess material here just to make it fit properly. Right, I've given that a wee file. So now I'm just going to put in the vise here, and I can put a couple of screws in to hold it in place. There are two holes here set aside for this job. Okay, we can now remove the fan. We don't need this here for a second. And I'm just going to put it back in the vise here like so. And that's going to give me something to put pressure on down while I attach the last piece. Now, if you're wondering why I'm doing this with a hand screwdriver, if you try using an electric one, it will probably damage these top edges here. So the hand screwdriver is the best for this option, and that will just slide on like so, which will give me my dust collection hose quite nicely. I'll leave that to dry and give it a bit of a paint, and once I've done that I'll be able to refit the motor back in here, and we'll go from there. Right, now while the paint is drying on my fan unit, I'm going to look at focusing the laser. Now this is something we need to get set pretty accurately, and there is a very simple way of doing this. What I've done first is I've removed the laser just off the shoe bracket, just removed the two screws holding it, and off it comes. We need a couple of items. One is a screwdriver. Now this is not the right screwdriver to use to adjust the laser. Here is the lens on the laser, just here, and while I can get the screwdriver in there and move the little focusing collar here around, this is the correct screwdriver for the job. It seems to be a bit oversized, but it will go into this slot here nicely and allow the laser to be focused with no risk of the tip of the blade going into the lens and scratching it, unless I'm very, very careless. So it can't slip onto the lens, and that's important. You don't want to damage your lens. Okay, first job is to connect the laser and power it up. Before powering it up, we're going to have a quick talk about safety, and it is absolutely critical that you have safety glasses whenever you use your laser. You need to purchase glasses, safety glasses that match the wavelength of your laser. This is a blue laser, and these glasses, they're sort of orange in colour, are designed specifically to block the light coming from the laser. In actual fact, you can't see any blue through it at all. On the lenses here of the laser, it actually tells you what the optical density of these safety glasses are, and these ones here are rated at 7. You can also buy other rated glasses. I went for the highest ones I could find. The better quality ones are obviously going to cost you more, and it all basically depends on how much you think your eyesight's worth, because you only ever get one pair of eyes. So I've gone for the best ones that I can find. Okay, the next part we need to focusing the laser is to know how much we want to, how far from the body of the laser here we want the beam to be focused at. And the way to work that out is measure how high the shoe is. So this is 55 millimeters, and the bottom is 12 millimeters, so that makes a total of 67 millimeters. I want the LaserShoe to sit 9 millimeters above what is I'm engraving, so add another 9 millimeters to that, and we end up with a grand total of 76 millimeters. That's around about 3 inches. So I'm just going to lay my ruler up against the body of the laser, and that's because the body of the laser will be sitting on the top surface here. Now the next piece of the focusing aid is a piece of angle iron steel. Now the reason we're using angle iron steel is it won't burn to start with. If you put wood there and try and check where the spot is, it's just going to burn the wood. You're not going to see anything. The steel is not going to burn, and what we're looking for is to see the diameter, well, see the point at which the laser is most concentrated. That's at its focal point. When we move it away from that focal point, either side the dot will get bigger. We want the smallest possible dot showing up on our angle iron, and the angle iron is just perfect for the job. Right, first thing we're going to do is put on our safety glasses and fire up the laser. Okay, the laser's now been turned on. If when you turn the key and push the button, the laser doesn't come on, you will have forgotten to issue the command in Mach 3 to actually turn the beam itself on. So you can either do that or just simply remove the TTL lead from, well, this particular laser anyway. The beam will come on if there's no signal at all going, no wire going to that lead. Okay. So you can see here on the angle iron the spot here, and it's huge basically. This spot is definitely not focused at that point. We want to make sure the ruler is hard up against the body of the laser, and that's going to give us our accurate measurement, and we're just going to move the angle iron in until we get the smallest spot we can on the angle iron. And you'll see in a second that will become very, very obvious when we are at the right point. And there it is there. Notice we got this interference pattern here, and the spot is very small. What we saw there before, I'll just move it sideways, it's burning through the layer on the steel, producing that very bright spot, and then it's coming through to clean steel and giving this reflection here. I'm reading the ruler here, and that says 76 millimeters, and that was the figure I was aiming at, having already focused this laser. As I move the angle iron in past the point of focus, the spot now is starting to get bigger, and it's no longer that really high intensity light that we were seeing. So I'll just pull it back this way here, and there we are, there's that high intensity spot again, and we just read the figure, and again it's 76 millimeters, so that's exactly where I want it to be. Now to focus the laser is relatively simple. You turn the laser off. You don't do it while the laser's running. You grab your oversized novelty screwdriver here, just put it into the focusing ring, and should you wind the ring in, the focus point on this particular laser moves further away from the body of the laser. By winding the screw out, the focal point becomes closer to the laser. Just keep doing those adjustments, and very quickly you will get it to exactly where you want it. It's basically as simple as that. The time has now come to discuss connecting the laser to Mach 3. Now I can't really speak for other laser types, and there's an endless number of them out there, or for that matter all the endless number of breakout boxes that people have, but this is the one I've used, and I'll tell you how I've connected mine. This is the Gecko G540, It has outputs here, 4 outputs that drive the stepper motors. We have our parallel port here that connects back to Mach 3, and we have a selection of screw terminals on the back here, or on the side I should say, that connect the power into it. There are inputs and outputs on this. I'm going to use pin 1 on the parallel port, and that connects to pin 6, or screw terminal 6, on the Gecko drive, and it's called output 2. It's designed primarily to switch on and off a relay, but it works very well switching on and off the laser as well. There are 3 terminals on the laser, and there are a total of 4 connections we need to make. 3 of them are done here, and 1 is done back at the Gecko. Or 2 are done back at the Gecko actually. The laser requires a 12 volt power supply, and that the positive of that 12 volt power supply connects to the pin labelled VCC, so that's your positive 12 volts. The next pin on here is the ground, and that connects to the negative side, of your 12 volt power supply. The third pin here is the TTL. Now that passes through the little switch box I made here, just a straight pass through, and will go back to your controller, where it will connect to pin 6 on your Gecko drive. The last connection is not done up here, but it's critical or it won't work. The ground of the laser, i.e. the negative of your power supply, needs to connect to the ground of the Gecko G540. Without that, the Gecko cannot turn on and off the laser. So you must connect the negative of your power supply to the ground of the Gecko G540. According to the documentation, that's screw terminal 12 on the Gecko drive. So those are basically the only connections you need to make from the laser to the Gecko to make it work. On the Mach 3 side of the laser, I've set up a new axis, the C axis. All I've basically had to do is enable the axis. I've set up a step port and step pin, and they are just an unused port on my setup and an unused pin. Just use anything you like there. It has to be valid for it to work. You have to use real pins, but if you've got spares, I suggest you just use them, because we're not actually using the step at all. What we're interested in is the direction. You have to set up your direction, and I've used the same port as I did on my other 3 axes here. So port 1 and pin 1. That was the pin 1 on the Gecko G540, which is used to control the output. That's the only thing that's important here. Just leave it set active low, and that we'll be using that to toggle on and off the laser. Basically, a negative value sent to the laser will turn the laser on, and then when we tell it to go in the positive direction, the laser will switch off. It's as simple as that. So this is looking in the configuration pins and ports, and these are the motor outputs we're looking at. The only other piece of setup we have to do, as if we get out of here, is in the motor tuning. Again, this is another screen you'll be pretty familiar with, having set up your own machine. And here we are. What I've done is I've set up 1 step per unit. I'm using millimeters, so 1 step equals 1 millimeter. It's not critical because all we're using is the direction anyway. What I have done is I've set a reasonably high velocity of 15,000 millimeters per minute and an acceleration of 15,000 millimeters per second. I've just set the step and pulse direction timing to 2 microseconds. And that's it. That's the setting up of the laser. Right, well, the paint is now dry on my vacuum unit. As you can see, I've painted the cap there a different colour. Take that off for the second. The first thing to do is we need to prepare the motor for installing. These motors come in different types, but basically they're basically the same size. Their outlet vents are about the same size, give or take a millimetre or so. They're designed to run all day, so there's no issue there. There are slight differences between these. If you notice here, the wires on here are red, black and white. On this one here, which is the one I'm going to use, the wires are red, black and blue. Now what I've done is I've cut the blue one off. This is the speed sensing wire. It's not used. The black and the red are the ones that provide the power to the motor. On this one here, the black and red again would be the power for the motor, and the white is the speed sensing. In actual fact, it's got written on there, red positive, black negative. Okay, so the first thing I'm going to do is I'm going to mount the motor back into my unit, and if I haven't got carried away with the painting here, it will all fit together, which thankfully it has. Now I'll just line it up, the original screw holes that I had in here, and screw this in place. Okay, that's now in. Next I need to do something with the wires here. What I'm going to use is one of these small joiner blocks here, and I'm just going to screw the block to the MDF here. This is going to provide a nice termination point for the wires. So just I'll just put the positive in one of these here, and the negative one in the other. So next what I've done is I've just got a piece of wire, and I've put a socket that matches the plug on the power pack. I'm going to use a 12 volt power pack to feed this, 12 volt 1 amp, and I've just got a bit of wire here. So it's important to get the polarity of this right, or you're likely to damage your motor. It certainly won't run if you got it round the wrong way. I happen to know the one on my piece of wire here, the one with the stripe on it, is the positive, so I'm just going to put that with the positive, and the other one is going to go with the negative. Right, well that's all our wiring done. I'll now quickly plug it in and see if it works. Well, there's no doubt about that. Plenty of air coming out here. Here's the plug pack I'm using for this particular job, and as you can see the plugs just match together quite nicely. This is just something I had laying about, think most houses probably have stuff like that laying about. Okay, well that's all the electrical work done. Next I need a mounting bracket. Now how you mount this here is going to entirely depend on how your machine is built. Mine, I'm going to get away with 2 angle aluminium brackets. First one is just going to go on the back here and sit flush. So I just got a piece of 20mm by 20mm angle aluminium, and I put 3 holes on one side and 2 holes on the other. So basically I'm just going to sit that flush and put a couple of screws into the angle aluminium. Okay, well that's my bracket in place there, and that's probably enough to hold it anyway. But I'm going to put a second angle bracket just on this side here, but I'm going to attach that angle bracket to the machine, and then that will locate it on here. So let's take it over to the machine and put it in place. Just down in this area here is where I've chosen to put the vacuum for my machine. So I'm just going to quickly route the wire up through the top here. We'll finish the routing of that later. And this here will just sit in here like so. I've already mounted this angle bracket in place. Again, just a piece of angle aluminium. So all I'm going to do is put a couple of screws in place. Well, that's mounted in place now, and it's really solidly in place. Now, when I want to connect the hose from the LaserShoe, I'll just bring it down and push it into the hole here, and that's it basically. It'll just sit there in the hole, like so, and the hose will be able to move backwards and forwards. It won't come out of there very easily. The other hose will just slide straight onto there. Next I need to route the cable for the power of this unit. Routing this power cable to the front of my machine where I can actually pick up the power is going to be very simple. Indeed, this piece just slides out. I can now just lay my piece of wire in, just drop it down here, and slide this piece of MDF back in place. I can now put my plug pack in and just simply connect up the wire like so, and the fan unit now works. When it's not in use, it's important to put this cap onto the inlet of the fan, simply because any wood chips that get cut off during other woodworking will fall down into there and then it'll be sucked through the fan, and the fan just won't appreciate that. So when not using the laser, simply put the cover back on. First thing we need to look at is the alignment of the laser with regards to the shoe. because we have absolutely no idea where the beam is going to go. If we could turn the focus, turn down the intensity of the beam, which I can't do on this particular model, then we could probably turn it down, raise it up, look at where the spot was, put a little X there or whatever, or move it to the appropriate place, then set it back down to the focus height and all the rest of it. But even doing that has its problems, because by the time you've raised it up high enough to actually see and work out exactly where it is, the spot is probably going to be quite large, and you'll be guessing at best. So you'll remember when we first started building the shoe, I made sure that there was no side play in the shoe with respect to the back plate of my router. And the reason for that was so that when it went onto the router, it was always in the same place. It goes back in a repeatable fashion. If there was a little bit of side play, I could either work on removing that, or alternatively just make sure that the shoe is always put on at the same angle, so I might always cock it to the right or to the left each time. And so long as I do the same thing every time, the registration marks we're about to put on will always be correct. Okay, so what I've done is I've in Mach 3 basically turned on the laser. The laser's not actually switched on, but what I'm going to do next is put on the safety glasses, turn on the laser, and it's going to make a spot on this piece of MDF I have clamped down to my table, and that will that'll show me where the laser is to start with. So I'm just going to quickly turn it on, like so, put a little burn mark in it, turn it off. Okay, now we can move the laser back. And here we have a spot. So we can now bring the laser shoe forward until it just sits above that dot. And I'm going to take the shoe down, and using a square, I'm just going to square down the to that dot, to the centre of the dot, like so. Right, now black is not going to show up very well on my shoe, so I've got a fine blade here, which I'm just going to use to cut through the paint and into the MDF. There we go. I'm now going to do the same to my Y, but before I do that, I need to reset my machine back to X0, Y0, because before I put this dot in, I zeroed my X and Y. So I'm just going to raise the Z up a little bit, and go to Y0 there, and X is already at 0 because I only moved it backwards. I can now move it to the side, there's the dot there, and I'll do the same again. I'm going to put a mark here, and when I'm finished I'm going to move the axis this way here and put a mark on the other side. Then basically I can always set my X0, Y0 to where I want using these marks here. So here's how simple it is to set up the laser shoe. Simply raise the router, slide the shoe onto the router, tighten on the Allen key at the back there, just to so it's on firmly. Connect the plug which supplies the power to the laser. We next remove the protective cap from the fan unit and take the hose from the LaserShoe and just plug it in like so. That'll stay in there nice and firm. We then take my dust extractor hose and that just plugs on to the output of the fan unit. The other end is taken outside to where the fumes can dissipate. Lastly, we take our material and place it on the table. I've just put an X on a piece of tape here in the centre, and first thing we need to do, you can either clamp it down, but remember you've only got 9mm of clearance between here, just a couple of nails may do, or just leave it as it is, because its own weight is enough to hold it in place as well. So I'm just going to take the shoe down, move it across, and just jog it around until the line here lines up with the start of my X, and there it is there. And I'm just going to set that to 0 in Mach 3. Next, I'm going to bring it across this way here, and I'm going to use this mark here on the Y, line that up with my mark, just back a little bit, that's it, and I'm going to set Y to 0. Right. Last thing I need to do is basically crash the shoe into the table right on top of my workpiece, like so, and I'm going to set Z to -9. Now what I have to do is set a go to 0, and there it is. That'll be right over my spot, and the LaserShoe is now focused. The one thing I should have done before that, of course, was remove the tape. So I can just remove the tape. Tell it to go to the origin point. And there we are, ready to start the engraving process. Well, I hope you've enjoyed watching the LaserShoe build, and hopefully you'll build one for yourself. If not, I hope it's given you a few ideas on perhaps something you can build yourself one day. Okay guys, well, thanks for watching, and we'll catch you later. Cheers.